Okay, so let's talk about algebraic expressions now. Okay, much like numerical expressions, okay, but an algebraic expression is made up of a variable, a constant, and an operation. A variable is the letter that stands in the place of a number. Okay, so that's just any unknown letter standing in the place of a number. The constant, the constant is the number by itself. And then the operations are your addition, subtraction, multiplication, and your division signs. Those are your operations. So an algebraic expression has a variable, which is a letter, a constant, which is a number, and an operation, which is add, subtract, multiply, or divide. Okay? When you solve for a variable, you solve by using the inverse operation, which means the opposite. Okay, we've talked about that before with multiplication and division. So you solve by using the inverse or opposite operation. So for example, 5 plus y equals 12. So what we're going to do is we're going to try to isolate the y or the variable and keep it by itself. So I have to take this 5 and I have to move it over to the 12. So 5 plus y, 5 is a positive number. So the only way to change that or move that is to do the opposite of addition, which is subtraction. So we're going to put minus 5. So if you have 5 and you take away 5, you have 0, right? So we're going to take 5 away, and then we're going to come over here to the 12, and whatever you do to one side, you do to the other. Okay? Let's write that down. What you do to one side, you do to the other. It's kind of like the golden rule. Okay, that's our math golden rule. Whatever you do to one side, you do to the other. So 5 minus 5, these kind of cancel each other out. So I'm left with a y by itself. And then 12 minus 5 is 7. So that means y equals 7. Now we check it by substituting y for that number 7. So my expression was 5 plus y equals 12. So I'm going to rewrite it. I'm going to say 5 plus 7, because y equals 7, equals 12. So 7 plus 5 is 12, and that equals 12, so y equals 7 is correct. Okay? So we solved it by doing the inverse operation, and then we checked it by substituting that letter for the number that we got. So the next one says x minus 5 equals 20. Well, minus 5. So the opposite of subtract 5 is to add 5. Those cancel each other out, and I'm going to come over here to the 20, and I'm going to add 5, which makes it 25. So x equals 25. And you notice that my x is kind of a cursive x, because it doesn't mean multiply, it just means x. So now our problem was x minus 5 equals 20. We're going to take and we're going to say x is 25 minus 5 equals 20. So I substituted the x for 25. 25 minus 5 is 20, which equals 20. So that means x equals 25. It was correct. Okay, let's look at some multiplication. Okay, when you are multiplying, you'll have a letter and a number side by side, and that means to multiply. So when you see 4y equals 16, the 4 and the y side by side means to multiply. Okay, so the opposite of a multiplication problem is a division problem. So we're going to divide by 4. So these two cancel each other out, and y is left on its own. And then I'm going to come over to the 16, and I'm going to say 16 divided by 4. Okay, it's written as a fraction, but isn't a fraction just a division problem? Yes, it is. So 16 divided by 4 is 4. So let's rewrite it. 4y equals 16. So 4 times 4. Okay, so that's my problem. I took the y and I substituted it for that number 4. A number in a parentheses side by side like it is means to multiply. 4 times 4 is 16, which equals 16, meaning y equals 4 is a correct answer. Okay, so I wrote the same kind of problem, but I flipped it, and I put 25 equals 5y. Well, this is multiply, so we're going to divide, and then come over here and divide 25 by 5. Leaving y by itself, 5 will go into 25 5 times, so y equals 5. 25 equals 5y. So let's substitute it in. 25 equals 5 parentheses 5. 5 times 5 is 25. 25 equals 25, so that means y equals 5. Okay, you see that all I'm doing is substituting when I'm trying to check my answer. And then to solve, I'm doing the inverse operation, meaning the opposite. Okay, so now let's look at a few how to write expressions. Okay, let's look at how to write expressions. Okay, so if we were to write an expression, an algebraic expression, you are going to the fair. It costs $15 to get in and $2 for each ride. So if we were to write that, we would solve it by saying 2R, which means $2 for each ride, plus 15, plus $15 to get in. Okay, so just to write the expression would be $2 per ride times R, which is the number of rides we're going to ride, and we don't know how many that is, plus the 15 to get in. Okay, so that's how you would write it if you were writing an expression. It costs $15 to get in and $2 for each ride. So $2 for each ride, so 2 times R, plus the $15 to get in. Okay, 2R plus 15. All right, if we're going to do another one, Mr. Rochelle has $70 and spends $6 on each of Y books. So we know that I have $70, and if I'm spending, I'm taking away, and I'm going to say 6 on each Y, so on each book. So 70 is what I have. We're taking away, so I'm spending. And then $6 on each book. And the Y is the number of books, because that's the unknown. Okay, so Mr. Rochelle has $70. I have 70. And we're going to take away, because I'm going to spend $6 on each of Y books. So minus 6Y. 6 of each. That each tells you you're multiplying. Okay, so that's solved or writing equations with a variable. Now let's look at some where we don't have a variable. Okay, I said without a variable. I didn't mean that. With a variable, but just different. Okay, so 4 times a number decreased by 6. So I'm going to take 4 times a number. We don't know what the number is. A number could be any letter. So 4 times a number. And then it says decreased by 6. Decreased means subtract. So there we go. 4n minus 6. 4 times a number decreased by 6. Okay, the next one, 7 less than a number. Okay, than is a switch word. Okay, it means you're going to have to switch your constant and your variable. So it says 7 less than a number. So you would think it's going to be 7 minus n, but no, it's a switch. So n minus 7. 7 less than a number. Okay? Remember that than is a switch word, meaning we are going to have to switch the way we write out our operation or our expression. So 7 less than a number is n minus 7. Okay? 6 times the sum of 9 and a number. 6 times, so 6 times, and then it says the sum of 9 and a number. Sum, meaning add, so 9 plus a number. So 6 times 9 plus a number. Okay, and because it says 6 times 9 plus a number, 9 plus has to be in parentheses. So you would actually write 6 parentheses 9 plus n. Or you could say 6 times parentheses 9 plus n. The point is you have to solve 9 plus n first before you multiply it by 6. Because it says 6 times the sum. Okay? The difference of 16 and a number divided by 2. Difference means to do subtraction. The difference of 16 and a number. That means 16 minus n. Okay? And then it says divided by 2. So in this case, you don't put the division sign and then 2. You put a fraction bar, 2. Because this means division. Okay, it means to divide. Okay, and when we're reading a word problem, you're going to read the word problem in order, and you're going to do your equation in order. So let's do an example. Okay, so this says, Kim opened a case of bulbs. The case contained 3 boxes of bulbs with 8 bulbs in each box. Kim threw 2 bulbs away. She took 7 bulbs out of the case. Write an expression to show 15 bulbs still in the case. So we're going to start with what we know. Okay? We're going to start with the case contained 3 boxes with 8 bulbs in each box. 3 boxes, 8 bulbs in each box. So that would be 3 times 8. Okay? All right. So 3 cases contained, or the case contained 3 boxes of bulbs with 8 bulbs in each. That's 3 times 8. That's what we know. Then we know that she threw 2 bulbs away. So we're going to subtract 2. Then she took 7 out of the case. So she also took away 7. So we're going to add those 2 together to find out how many total she did away with. Okay, so she had 3 boxes. So 3 boxes. We're going to just draw us a little picture. And each box had 8 bulbs in it. She took 2 from this box. And then 7 from this box. And we want to know how many she had left. We want to write an expression to show that there's still 15 left, right? So we have to add 2 plus 7, because that's the total number that she did away with. She threw 2 of them away and put 7 of them up somewhere else. Okay, so 3 times 8 minus parentheses 2 plus 7. So if we were solving this, we would say 7 plus 2 is 9. 3 times 8 minus, okay, you're going to solve next 3 times 8, which is 24. I don't have room, so I'm going to put it over here. 24 minus 9, and 24 minus 9 equals 15. So that means our expression 3 times 8 minus parentheses 2 plus 7 was correct. We wrote an expression to show that there are 15 bulbs still in the case.